welcome to Embedded Internals. This is 6th episode of our series, that is C System Fundamental series. In this episode, we are going to check comparison, logical and conditional operators. Until now, we have seen that values existed and arithmetics transformed them. This is the episode where we are going to see how decision making happens. Decision in C is ultimately becomes jumps in machine code. What it first is what it mean by computation versus decision. Until now we have done our operation on computation part. When we are saying computation, it means arithmetic operations. Like we have addition, subtraction, multiplication, division, modulus and many things. Post increment, pre increment, like this, and that is also on the signed and unsigned variables. So when we are arithmetic, like it is x is equal to a plus b, it produces some values or result. Now comes the decision. When we are saying decision, we are deciding what to do next. It is like after the compute we are comparing, and based on that comparison result we are executing the path. If x is greater than 10 or any value, do this. Else, if any other condition, do this. Have a look at the decision flow. In the case of machine, it is like we are computing first, and based on our computation we are comparing, and then we have multiple branches where we need to move to. Finally, we are executing our path. Whereas in the case of computation, we have seen that flow is like first move from the RAM to register. Do the operation, any operation, arithmetic operation, ALU will come into the picture. Now store that value back from the register to memory or RAM. So it is like load, perform and store. In C, we does not have any inbuilt mathematical truth. Rule is simple that 0 means false, whereas any non-zero value is true. Based on this, if we will see like example, if 0, no operation, or if any non-value like 100, if 0 then condition become true, we will execute. So conditions evaluates value. We are seeing conditions is evaluating the next decision. Zero is false, any non-zero is true. Just remember this. So if 0, print false. If let us take any other value, 100, print true. True, because any non-zero value will be evaluated. This is this is 0 value, so it is not being evaluated. Now let us make this. We have created a parameter variable x where we have value 0. Let us check by x. If x is equal to 0, condition will become true, right? If x is not equal to 0, let us see, false, because this condition now become true. We are evaluating. I will show you in the next. So first thing is that should be clear that 0 means false and any non-zero stands for true in our C programming, and conditions are used to evaluate values. Okay, so now second is comparison operators. Comparison operators, we have comparison operator like equal to, not equal to, greater than, smaller, less than, greater than, less than equal to, greater than equal to. These all are comparison operator. Comparison means either they will produce result as 0 or 1. Either the operation is true or false, right? So for example, when we have 5 is greater than 2. Is it true? Yes. Output will be 1. If 5 is equal to 5, true, output will be 1. So we are comparing two values using the comparison operator. Similar way, we have the less than comparison and the less than equal to comparison. So less than equal to, if 5 is either less than or equal to 5, right? Sorry, either greater than or equal to 5. If any one of the condition will meet, we will evaluate it as true. So 5 is greater than equal to 4, so it is greater than, so it will be evaluated as true. Similarly, if 5 is not equal to 5, false, because 5 is equal to 5. So when we are doing the comparison, it's simply in the machine code, it is like compare. Based on that compare, set the flag and return boolean. Compare, set flag and return boolean. So this will be the machine level code when we are doing any comparison operation. Now there is one most important thing, that is equality versus assignment. It is where people get confused. Equality is represented by equal to equal to, well assignment is simply 1. Okay, so when we are doing x is equal to 5, it means we are assigning value 5 to the variable x. So first assign, then evaluate. Okay, so if we will do, if x is equal to 5, in this case first we are assigning the value 5 to the x. Assignment work fine, then condition will be operated, so it will become true. Yes, x is equal to 5, so it means assign and then evaluate. Whereas when we are doing double equal to, so it is means we are checking for the equality. So it is comparison. Double equal to is comparison. We are comparing two value, no assignment, only comparison. So if 5 is equal to 5, here we are comparing. So if 10 is equal to 5, only the comparison result we will evaluate. So compare and evaluate, no assignment. In case of any assignment and operator, just when you are doing the compilation, use this flag -wall for any kind of warning. So we understand what a comparison operator, how the compare works, and it produces only the boolean result, either true or false. What are different kind of comparison operators and how equality and assignment differs. Okay, now comes the relational operators. It is equal, smaller than, greater than, smaller than, equal to, greater than, equal to. When we are doing this, simply we are checking the relationship from first to second, like age is 20. We are checking if age is greater than equal to 20. What is doing? Then evaluate the condition. So when we are doing the visuals of this, it is like load, then compare, load the variable, then compare, and then jump or do the operation branch. Comparison result is also a value, either 1 or 0. Here we have seen the branching operators equal to comparison operators, and in this comparison operator, these four are relational operators. Okay, now comes the logical operator. Logical operators combines conditions. First thing is combines conditions. So we have this and or not. These three are logical operators. This is and, this is or, this is not. Logical and. Output will be true only when both the two conditions will be true. So it is like both true, result will be true. Like one, we have x or y, 0 0 0 1 1 0 1 1. result, only this condition will be evaluated as true, other are evaluated as false. So output will be true only when both the condition is true. It is AND operation, 1 and 1, 0 and 1, 1 and 0, 1 and 1. Only this AND evaluated will be. Similarly, we have logical OR. In that case, if any one condition is true, result will evaluated as true. It is like 0 or 0, 0, 0 or 1, true, 1, 1 or 0, true, 1, 1 and 1 both true, result true. So true if either is true. Like for example, if we have we are checking if score is greater than 0 or some bonus parameter is set. Let's say bonus parameter is not set but score is greater than 0. True condition will be evaluated. Even when this condition is not 0, second is true, then also true condition will be evaluated. Only one condition needs to be true. Second condition will not be evaluated. The output will be simply true. One true, all true. Whereas in the case of logical AND, both condition needs to be true. If we have logical AND, same condition, if score is greater than 90 and bonus parameter is set, then only true condition will be evaluated. Whereas in the case of logical OR, if any one condition meet true, true condition will be evaluated. Similarly, we have logical NOT. It is like inversion. If the value is x, if a value x is true, evaluate it as false. If the value is false, evaluate it as true. So this is like inversion. Invert the condition. In the logical operations like a logical AND or a logical NOT, we have short circuit. Short circuit means if one condition meets true, second will not be evaluated. Or if one condition, first condition is evaluated, based on that second condition will evaluated or not will be decided. It is like if A and B. Suppose A is false. Now in the AND condition, if one parameter is false, the result will be false, right? So first A will be evaluated and this termed as false, B will never be evaluated. Let me show you an example of this. Similarly case in case of OR as well. If A or B. Now if A is 1, B will not be checked. It will be evaluated because okay, if this is 0, we can this is 1, any of the condition is true, true condition will got evaluated automatically. So second parameter will not be evaluated if the first condition is only evaluated, and if needed only then the second condition will be evaluated, otherwise not. Like if it becomes 0, we need to check the second condition as well. 0 or 0 is false, if 0 and 1 is true, so in that case second will be checked, otherwise it is not. Let me show you an example. This is a very simple example where if first is true, then function will be called, okay, or this we have logical OR. If we see, the output will be like nothing. First is true, it will not going to check the second, so it will not going to call the function, nothing. First condition true, it will simply evaluate this, it will not going to check the function or function f where it is written any statement or anything. Let's see, we will be marking as 0. Now 0 is there, so it will go to check the second parameter also. If it is 0 or false, then this is evaluated. So the evaluation depends on the first condition only. This is the logical short circuit. It is like evaluate left, take the decision, and maybe if only needed, then only evaluate right. Like in the case of 0, we have to evaluate right. Otherwise, we can, if we are able to take the decision based on the evaluation of left, that's fine. Okay. What is a practical use of this short circuit? Sometime when we are dealing with the pointers, we first check if the pointer exists. If pointer exists, then perform the other operation. In that case, we use this short circuit parameter. Like, first we check the pointer existence. If anything valid value in the parameter, then only we will move to the next value. If this pointer exists, then move to the next address this pointer is pointing to. If there is no pointer here or null pointer or some problem, this condition will never be evaluated. So check pointer then access. This prevent invalid access. That is safe pointer check. This is safe pointer check and it prevent invalid access. Now let us move to conditional operators. Ternary operators. Matlab 3 operands are evaluated at a time. It is question mark and colon. If this condition will meet, evaluated as true, then A, or if this condition is evaluated as false, then B. So like for an example, so if A is greater than B, condition will true. In true case, maximum will be A, whereas in the case of false, max will be B. Compact decision logic. Evaluate, branch, produce result. So first it is evaluating, then branching, and then based on that it is producing the result. We should avoid nested ternary warnings because it impact the readability of the code, are mostly difficult to understand. Like we can say if A is B, then C, then D, or D, E, question mark, F, kept on going. Nested ternary operator should be avoided. Now something we need to be very take care, like in the if condition, if we are evaluating any negative value, like if 100, although this value is negative but it is the non-zero value, so it operates as true. Only in the condition if 0, then only the condition will become false. Any non-zero value will evaluated as true. Even in the case if we will do if 10.5, condition will be true. Only 0, or we can say null is also 0, then condition will be false. One thing also we should avoid, that is floating point comparison. So this is the truth. If only check for non-zero value in if is evaluated as true. Second is what should we avoid? Nested ternary operator we have seen. Other than that, we should also avoid floating point comparison. Like example, double a value is x, 0.1 plus 0.2. It is evaluated as 0.3. Okay. So if we are doing x is equal to 0.3 or equal to comparison, may fail because floating point inside if should be avoided. Avoid. May result depend upon the compiler warning. So it will become dangerous when we doing any equality comparison in case of floating point. So we should avoid this. Now, based on all the conditional operators, we have one machine level branching. What is that? Which is mostly used in our Linux kernel. Machine level branching. Like in the comparison operations, we have x, we have x is greater than 10. When we will compare this in the assembly, it is like compare from any register EAX 10 and jump to particular level. Jump any level, if else whatever the level is. So how the CPU is going to evaluate? It is like compare and jump. compare and jump. So this is like in the comparison, condition comparison. Now in the case of branch prediction preview, we have two branches in the kernel, likely or unlikely. Modern CPU. So we have likely branch, and we have unlikely. These are for optimization. So I think we have GCC Boolean corresponding to this, when we declare likely X or unlikely X. Likely X means it is a hint to the compiler that the expression X is mostly going to be always true. They all are for compiler. Mostly going to be true. Whereas in the unlikely case, it is almost like it is always going to be false. Likely values to true and unlikely for the false. Frequently, unlikely and likely, they unlikely are used inside the kernel, and that is also for the error checking. So we can say that comparison do not control execution. Comparison only produces the value based on the operator we are using. It is the branch which is controlling the execution. Okay. Now in this episode we have seen the conditions programs are defining by, but underneath at the computer level everything is bits only, 0 and 1. So at the computer ultimately every decision is going to be based on bits level only. So in the next episode we are going to cover bitwise operator. Stay tuned for same. Thank you.